Yes, sir, you are audible. Siddharth, principal sir has joined. So we may start now.
Okay, sir. Respected Principal Sir, Haldia Institute of Technology, Officer on Special Duty IQAC, Haldia, Dean School of Engineering, HIT, Head of the Department Chemical Engineering, HIT, faculty members and dear participants. A very good afternoon to everyone. Myself Dr. Siddhartha Shankar Boksi, Associate Professor, Department of Chemical Engineering, Haldia Institute of Technology, and convener of this event. First of all, I would like to welcome all of you in this 5 days online faculty development program on Industrial Wastewater Management IWWM-2023, organized by Department of Chemical Engineering, Haldia Institute of Technology in association with IQAC, HIT, Haldia. Now we will start our formal inaugural session, and I would like to request our head of the department, Professor Dr. Sunil Boron Kuila sir, to give welcome speech. Over to you, sir.
Thank you, Siddharth. So, good afternoon, everybody, and most welcome to our FDB program today. We are honored to have such a distinguished group of faculties joining us. And today's event promises an engaging and enlightening experience for all of us, actually. And the topic of our FDB program has been selected as Industrial Wastewater Management. And I believe that in this particular area, so many faculties are involved with their research work. So, and we have invited the experts from the industry, from the academia, who are in regular basis, they are exercising this particular area and exploring the area in daily basis. So by sharing the knowledge, we will be enriched enough for further progress of our research work. So let's open our minds and hearts to new ideas as we come together to learn new facts and sharing the knowledge. I would like to warmly welcome our guest speakers and facilitators who have generously agreed to share their expertise with us. Let us all take advantage of this opportunity to grow and learn together. We have an exciting lineup of topics and activities for the day. So let's make the most of it. A big thank to all organizing committee for putting their efforts and hard work for executing this program. Let's all work together to create a welcoming and inclusive environment where all voices are heard and respected. So let's begin this journey of learning and discovery together. Thank you for being here.
Thank you, sir, for your valuable words. Now I would like to request Dr. Tarun Kanti Jana, Dean School of Engineering, HIT, Haldia, to say few words about our FDP. Sir, please.
Am I audible?
Yes, sir, you are audible.
Okay. So, good afternoon, ladies and gentlemen. Respected Principal, Professor Subodh Kumar Mondol, Mr. Amal Datta, Officer Special Duty IQAC, Head of the Chemical Engineering, Professor Sunil Kuila, Convener Dr. Bokshi, and Co-Convener Dr. Bej, and all other members of the organizing committee. At the outset, I would like to take this opportunity to convey my sincere regards and gratitude to all the members of the Chemical Engineering Department of HIT Haldia for taking this wonderful initiative of organizing 1 week long faculty development program on a very contemporary topic, that is industrial wastewater management. this particular theme, the topic has got more relevance as far as our HIT chemical engineering department is concerned, because our institute is situated in a chemical engineering hub that surrounded chemical and process industry, big areas like IOCL, Haldia petrochemicals, MCPI, and other processing industries. I believe that this wastewater management and the treatment is one of the most challenging issues faced by the different process and chemical industries. And when this wastewater level or the contents or the pollutant level crosses the limited values as earmarked or identified by our regulatory bodies, then it becomes a threat to the aquatic animals and in large for the entire society. Now, I don't have knowledge about this particular topic, but as a common people, I can say that this alarming threat of this contaminants of the pollution becoming and extremely pose a extremely high threat to all the living entities in this soil. And this particular problem is part and parcel of the process industries. And each such process industry have their effluent treatment plan. They have their plan how to reduce level of contaminants before it is to the sewerage. But still, the level increases to such a high extent that it creates a problem and it is a precarious to the living animals. So this particular initiative of organizing FDP programs, where I was going to the list that lot of resource persons from the neighboring industries, CL, MCP, Haldia petrochemicals, as well as from the academia, they will share their experience, they will discuss the different issues pertaining to this wastewater management and treatment, and how we can control or regulate or curb these pollutants so that have our livelihood, we can protect our environment and also improve the efficiency of their operations. So young faculty members, they will find it a very potential platform to enrich their knowledge for their upcoming days teaching, and it will also throw more light on the various research issues to mitigate the challenges of the industry for the mutual benefits. I don't have much idea, but at the same time, I will be able to venture out to the very details of this particular topic. But one thing I would like to suggest that since we have got a lot of neighboring industries and our faculty members of the chemical engineering departments have got their very good connection with the neighboring industries. So if we collect the day-to-day data as regard to their process, as regard to the pollutant levels, you can make use of the emergent techniques of the data science and machine learning so that you can better predict what is going to happen and how you can control or how you can suggest for better control so that the can reduce their minimum level. So once again, on which regards and thanks to the organizer for selecting this particular very contemporary and emerging topic. I think all of us who are associated with this particular event will be extremely extremely fruitful, and of course for our research jointly with the industry people. So I wish all success to this particular event. Thank you very much.
Thank you, sir, for your encouraging words. Yes. Thank you, sir, for your encouraging words. Now I would like to request Mr. Aman Kumar Datta, Officer on Special Duty, IQAC Haldia, to say a few words about our FD. What is that?
Respected Principal, Professor Shubrata Mandal, Professor Jana, Professor Koilab, all the faculty members of Chemical Engineering Department, and the industrial representatives who have taken part in this FDP on behalf of the industry. So I convey my sincere appreciation to all of you for organizing this program and industries in particular who have agreed to share their thoughts on these on this particular relevant topic. I would only say, if I am not mistaken, our chemical engineering department is already on the way. They're already conducting a study for more than last 6 or 7 months. They have started a study on examining the various effluents coming out of the different industries and ultimately getting into the river Ganges. So I hope this study will be completed very fast, and it would have been much better if this study had been completed and this in this particular FDB this could have been discussed. Uh, I have nothing more to add because Professor Jana and Professor Kul have already said a lot of the relevance of this particular topic. But I would only say after this FDP, I would request the chemical engineering department, the principal and the dean of the dean sir also that once that after we complete our study on the effluents that we are whose samples we have already collected from different sources, including the exit point near Greenbelt Canal. Once we get then we will call the industries and we should have an open house discussion on our findings. That will be very much relevant for coming out of some kind of a solution how to ultimately address the situation on the real life data. So I would request Professor Quilla, if you have the HOD Chemical Engineering, that if you can expedite completing that particular study to be followed up by open house discussions with all the industries who are a part of the entire wastewater management and whose effluent we have already collected. So apart from this, this is I hope this the industrial practices adopted by the various industries would be discussed. They would tell what are the practices and what kind of technology they are using in treating their effluent, their what kind of measures they have taken for towards zero discharge. So this would definitely open a very good forum for the faculties who would come to know, and they can our faculty members, I believe, will also be able to share their thoughts on what should be the wastewater management and how we can combat the menaces of this particular, this wastewater that the problem that the country as a whole and particularly industrial area of Haldia as a whole is facing. So thank you very much. I again congratulate the chemical engineering department for organizing this seminar and the industries also who have agreed to come forward and speak their and speak the technology they are going to they are using and what all actions they have taken. So which will definitely improve the knowledge base of our faculty members and then the academia and the industries together will work out some strategy to the issues which are still to be addressed in this particular area. Thank you very much.
Thank you, sir, for your precious words and encouraging us. Now I would like to request our honorable principal, sir, Dr. Subrata Mondal, to deliver the inaugural speech. Over to you, sir. Sir, am I audible?
Yes, yes.
Sir, please start your speech.
Okay, I am just being in contact. Just a minute. Hello.
Yes, sir.
Sir, principal sir, your voice is not coming actually. Siddhartha, you check the mic of principal sir.
Okay. Sir, turn on your microphone. Sir, please turn on your microphone.
Bonali, Bonali, are you here?
Yes, sir. Yes, sir.
You go there. You go there. The principal room you go.
Okay, sir.
এখানে সবই ঠিক আছে তো? না না এখানে সবই ঠিক আছে আসছে স্যার হ্যালো মাইক্রোফোন
Yes, sir. Yes, sir. Now you are audible, sir.
অডিয়েবল
Yes, sir.
am I audible
Yes, sir. Now you are audible.
ওকে ওকে
Now I would like to request our honorable principal, sir, Dr. Subroto Mondol, to deliver his inaugural speech. Please, sir.
Good afternoon to everybody. It's a very moment. I think audible. What I want to say, very disgusting session which I have faced. Everything is all right here, but I don't know why my voice is not going there. Anyway, with due respect to all of you, I am really happy to know that our chemical engineering department is going to organize a faculty development program on the topics of wastewater management. Actually, really, it is a very important thing because we know that wastewater management it is a very vast thing because to protect our water resource as well as human body from toxic element, this wastewater management is very much required. And there are a number of tests there. Our experts will discuss about that. how it will be managed. Anyway, faculty development program also give us some benefit to our faculties to learn, to upgrade the knowledge as they can meet their challenge, which questions will come from the students as on date. So every faculty has an style of their learning or their teaching. So to maintain the teaching with upgrade knowledge, this type of faculty development program should be organized each and every institute. So really, our institute always take care about this. Every time they are organized this type of faculty development program to upgrade the knowledge of our faculties. So we are always at the top of the list of our engineering college in our West Bengal. With these few words, I conclude that this faculty development program will get success, and thank you all.
Thank you, sir, for your inspiring words. Now, dear participants, we are almost to the end of our inaugural session.
Sir, mute yourself. Sir.
Sir, please mute yourself.
Mute yourself. Mute yourself.
Now, I would like to request Dr. B. Bech, co-convener of this event, for giving a vote of thanks. Dr. Bech, please.
Thank you very much. It is indeed a special moment for me to express the vote of thanks. First of all, I would like to extend my heartfelt gratitude to our chief patron, Dr. Lakshman Chandra Seth, Delete, ex-MP Lok Sabha, Honorable Chairman, IQAC Haldia Institute of Technology. Then I wish to thank our patrons, Mr. Ashish Lahiri, Honorable Secretary, IQAC HIT, and Mr. Sayantan Seth, Vice Chairman, IQAC HIT, for providing us infrastructure and resources to organize this 5 days online faculty development program. I would like to express my sincere thanks to our advisory committee member, Professor Dr. Subroto Mondol, Principal, Haldia Institute of Technology, for giving his valuable time to grace the program. I wish to extend a vote of thanks to all advisory committee members, Dr. Anjan Mishro, Registered HIT, Mr. Amol Datto, OSD IQAC Haldia, Dr. Torun Kanti Jana, Dean, School of Engineering HIT, Dr. Debashish Das, Administrative Manager HIT, and Mr. Sudipto Kumar Basu, Finance Manager HIT. A big thanks goes to our head of the department, Professor Dr. Sunil Baron Kuila, for giving us inspiration and lots of encouragement to organize this program. Without his constant support, it could not be possible to organize. My sincere thanks to all deans and head of the departments joined here. On behalf of the organizing committee, I would like to thank our esteemed guest, speaker, and all the delegates for gracing the occasion with their warm presence. I would be failing in my duty if I do not extend a vote of thanks to Dr. Anupam De, Associate Professor, School of Applied Science and Humanities, for providing us the technical support for this event. Last but not the least, I want to extend a vote of thanks to our organizing team members, faculty colleagues, and staffs for making this event happen so beautifully. Once again, thank you all for becoming a part of this program. Thank you.
Thank you, Dr. Bech. With this, we are ending our inaugural session here. Now, within few minutes, we will start our technical session. Please stay with us.
Actually, today's speaker, Mr. Asit Kumar Mitro, Deputy General Manager, Haldia Petrochemical. He has already present. He has joined there. So I would say Siddhartha
Yes, sir.
to welcome him and provide the necessary arrangement what he requires.
Okay, sir.
Good afternoon, everybody.
Now
Shall I proceed?
Okay, sir. Just a
Just a minute, Asita, just a minute.
Okay.
Let them to introduce you first.
Okay. Okay.
Now I would like to welcome our eminent speaker, Mr. Osit Mitra, Deputy General Manager, Manufacturing at Haldia Petrochemicals Limited. Mr. Osit Mitra obtained his BTech in Chemical Engineering from University of Calcutta. He has more than 33 years of experience in petrochemicals and refinery field. He involved since project phase to plant erection, commissioning, startup, operation, production in different chemical process plants. He worked as shift engineer operation at IFB Agro Industries Limited, Nurpur, West Bengal. Then he worked as senior production engineer operation at Consolidated Fibers and Chemical Limited, Haldia. He also worked as Reliance Petroleum Limited, Jamnagar, Gujarat. Currently, he is working as Deputy General Manager, Manufacturing at Haldia Petrochemicals Limited. Today, he will be giving his lecture on petrochemical industry, wastewater treatment and management, and sustainable development towards global environmental protection. Now, I would like to request Mr. Mitra to start his speech. Over to you, sir.
Thank you. Thank you, everybody. Now I am going to present about our petrochemical plant wastewater management, how we are doing. Just a minute, I am just sharing.
Sir, please unmute yourself. Please turn on your microphone, sir. Sir, it is in Google Meet that bottom of it. That is turn on your microphone, sir. Sir, please go to one time to the Google Meet. There it option is there.
At the bottom of your screen. At the bottom of your screen, there is a sign of mic. Siddhartha, is it possible from your side you can turn it on?
Just I'm trying. No, sir. There is no option here. Sir, left side. It is left side. Yes, sir. Yes,
Yes.
sir. Yes. Now
Yes,
you are on.
yes, yes. Now carry on. Now carry on.
Good afternoon, everybody. It is my privilege that I have got the opportunity to give a presentation about Haldia Petrochemicals Limited and how we are treating the wastewater. That I want to say. First of all, thank you to our HOD, Mr. Dr. Sunil Kuila. He has given me the opportunity. One thing I would like to comment on here that Sri respected our Lakhan said, only his dedication, devotion, this kind of Haldia Institute of Technology, Engineering Institute and Medical College has been built. I have a lot of respect and lot of salute to him. Now I want to give presentation about wastewater treatment, how we are treating actually wastewater. Before that, actually petrochemical industry, about some petrochemical, what kind of wastewater is generated, that some idea you should have, right? Actually, you know about naphtha, we have the naphtha cracker plant. Naphtha is coming from refinery. Actually, after oil exploration, refinery, some of the product you might be knowing, that is petrol, diesel. Naphtha is also one of the product. That naphtha, we are mostly it is imported from Arabian Gulf country. That naphtha, after cracking, value added product is being made. Actually, in our petrochemical industry, main raw material is naphtha. After cracking naphtha, the different petrochemical products like HDP, LLDP, PP products are actually we are sold out as a product, and liquid chemicals also we are selling out, that is benzene, butadiene, and your pygas sometime. Or pygas means pyrolysis gasoline, that is actually mixed with the for ms production. Actually we have a joint collaboration kind of thing, industry to industry. IOCL Haldia refinery, they are also their naphtha, what they are producing, that naphtha we are taking intern also. Sometimes we are giving them pyrolysis gasoline, they are making petrol, ms as a. So by this process, that effluent has been mostly generated from naphtha cracker unit. That effluent, how we are treating, actually our stringent norms is there as from pollution control board, that COD and BOD and TSS and pH, we have a limit, we have to maintain this. Not only that, our sustainable development or environment protection also is our main motto, because flora and fauna should not be affected because of our industry. Industry should not pollute anyway our beautiful environment. So whatever we are discharging to the environment, like here Hooghly River, or ultimately it will go to the sea. So that aquatic living organism, that should not be affected. You might be knowing that dissolved oxygen level, that's supposed to be minimum 4 milligrams per liter in the water. So thereby our living organism in the water body can survive. So that DO, dissolved oxygen level, to maintain that DO level, we have to reduce the COD, BOD. We have to maintain the COD maximum of 250 milligrams of per liter. That is the norms were given by Pollution Control Board. And after our discharge, there is a stringent regulatory body, that continuous emission monitoring system we have. Means continuous effluent what we are discharging, that quality going to the CPCB server, Central Pollution Control Board server. One thing I would like to say, if anybody having any doubt or any suppose abbreviated term I have used, you can interact, you can or later on you can note down and I can give the reply also. So to meet the stringent specification, one part, another part is environmental protection also. We need to treat the water properly. Now I am coming to treatment process. How we are treating. Actually, this is contaminated with. If you see, industrial wastewater treatment covers the mechanism of process used to treat waters that have been contaminated in some way by industrial or commercial activity prior to its release into the environment or its reuse. Actually, now because of global water crisis, we are also planning for recycling of treated effluent water. But sometimes what it happens, but recycling cost is more than our raw water purchasing cost. Then business point of view, it would not be justifiable. That's why we are also thinking in a lower cost. If we can do, then maybe that some water we can recycle. In HPL, WWTP wastewater treatment plant has been designed to treat the liquid effluent generated during process and otherwise from all process plants and IOP. Actually, mostly contributor is NCU, naphtha caca unit. Major pollutants, if you see in the effluent, the suspended solid, free and emulsified oil, sulfide, phenol, and dissolved soluble organic material. That dissolved soluble organic material coming in terms of BOD and COD, biochemical oxygen demand and chemical oxygen demand. That stringent norms given by Pollution Control Board or statutory body, that COD maximum should not be more than 250 milligrams per liter, and BOD is 30 milligrams per liter. That we have to meet. Not only it is our also a social responsibility that because of our industrial pollution or industrial discharge, that flora and fauna in environment should not be affected anyway. In that motto, we are also treating the water carefully. Actually, this is our design capacity, 3,600 meter cube per day. That means 150 meter cube per hour water we are processing. 150 meter cube into 24 hours means 3,600 meter cube per day. Plus sanitary effluent also means bathing water and sanitary effluent also. That also serving the slight purpose of food for the bacteria. I am coming later on how sanitary effluent also helping for the treatment process. And cooling tower blowdown. This cooling tower helping for heat extraction from the process. Suppose in NSU naphtha caca unit, there is a lot of heat exchangers are there. That heat to be removed through cooling tower. That cooling tower maintaining the cooling water quality, that blowdown need to give. That blowdown water also we are discharging through our effluent treatment plant, only controlling the pH, because pH we have the specification 6.5 to 8.5, and that on that range we have to maintain and we have to discharge. Then DM regeneration. DM means demineralized water. That demineralized water preparation during that time, the regeneration is required. The regeneration effluent also coming around 2000 meter cube per day. Then this wet weather flow, it means that during rainy season, huge water is coming. That discharging, because BOD COD very lower level, and we are also that when we are sending this water through flow meter, that instrument analysis is giving the BOD and COD range within the 250 and 30 milligrams per liter, then this water simply we can discharge. And raw effluent quality we have actually in our plant, that what quality water we should receive in our ETP, effluent treatment plant. That is normally 6 to 11. Chemical oxygen demand maximum this 655. But in unusual cases, it may go high as high up to 2000 milligrams per liter. In that case, we have a separate storage pond where we can store, and slowly that water we can take in our system for treating that water. Similarly, also BOD if high, then that water we can also keep in another pond and we can treat. Then sulfide content and oil and grease content. These are the phenol content also, that raw effluent quality, this kind of raw water quality we can expect and we can treat also. And here the WPCB norms and design quality of treated effluent. After treatment, what quality of water we should discharge to the river Hooghly, ultimately going to sea, that is the quality actually. pH is 6.5 to 8.5, COD 30 chemical oxygen demand 250 milligrams per liter, BOD is 30 milligrams per liter. And these are oil and grease maximum 10 ppm, and suspended solid TSS we are calling, total suspended solid maximum 100 milligrams per liter, and phenol is maximum 1 milligram per liter. And sources of effluent is NCU, AU, PP plant, LLDP plant, oil water sewer, OWS we are calling, oil water sewer, sanitary waste, cooling tower blowdown, DM regeneration effluent, and flare QOD also. Actually, treatment process is divided by three phases actually: physical treatment, chemical treatment, biological treatment. Physical treatment means bigger size of material like your dirt or any floating debris that we are removing, physical treatment. Chemical treatment means pH maintain. Suppose we have to add acid for neutralization. Mostly it is coming alkaline kind of water, so we need to sulfuric acid for lowering the pH. And biological treatment is, and another chemical we are using continuously, that is actually floculating agent, ferric alum. Thereby that oil molecules flocculation, or it will be bigger molecule, so that it will be easily separated from the main stream of water. And next is biological treatment. Here actually biological treatment, activated sludge process we have followed. ASP we are calling. Actually surface aerators are there. These surface aerators are continuously giving the oxygen to the bacteria. Initially bacteria has been grown. Okay, later on I am coming that. Before that, that physical treatment, how their bar screens are there, grid chambers are there, and tilted plate interceptor is there. That is actually physical treatment. This is actually TPI, tilted plate interceptor. Water is flowing this through this, and sludge is deposited here. From this bottom, sludge has been removed, and upper portion water has been outlet as a water discharge. And this actually operation takes place based on Stokes law, that is settlings of spheres in a Newtonian fluid. A spherical particle placed in a Newtonian fluid will sink if the buoyant force does not match or exceed the gravitational force on the sphere. The net downward force on a sphere is the difference between the settling force and the buoyant force. Basically, separation of bigger molecule, and it will go into the bottom, thereby as a sludge or heavier molecule it will be separated. Then chemical treatment. Then pH adjustment tanks, there sulfuric acid, 98% sulfuric acid we are using, and their coagulating agent ferric alum we are using as a coagulating chemical. And sometimes we need to add hydrogen peroxide. Hydrogen peroxide, if sodium sulfide content found high, actually NCU used as a sodium hydroxide, caustic soda, that sometimes forms with that sulfur, the sodium sulfide. That sodium sulfide, for treatment of sodium sulfide oxidation, that hydrogen peroxide we need to use to reduce the sulfide contents, or H2S also. And flocculation tank, sorry. Actually de-oiling polyelectrolyte. Sometimes if oil quantity very high, in that case sometimes we are dope we are calling de-oiling polyelectrolyte, special chemical we need to use. But normally it is not required to use. Coagulating chemical, what are the chemicals required for ETP operation? Coagulating chemical is ferric alum, 10% solution, nutrient and food for bacteria, urea 10% solution, molasses if MLSS. Actually, I am coming later. What is MLSS? Mixed liquor suspended solid came down to 1000 milligram per liter. Then we need to add molasses as a food for the bacteria. And dope and DWP, DOP, de-oiling polyelectrolyte, and DW, dewatering polyelectrolyte. When oil contaminants are very high, normally that time only we use. Normally it is not required to use. And hydrogen peroxide also, when NCU plant spent caustic oxidation unit not functioning, sodium sulfide content became very high. For conversion of this sodium sulfide by oxidizing chemical, hydrogen peroxide is used. Basically, this kind of reaction, Na2S plus H2O2, Na2SO4 plus H2. This H2S plus H2O2 ultimately sulfur and water. And bacteria is working here also. That I am coming later. How this bacteria. And chemical treatment, another important unit is dissolved air flotation tank. That's actually floating oil will be separated from TPI, tilted plate interceptor. Later on, whatever the emulsified oil, that would be separated by dissolved air flotation tank. That dissolved air flotation tank, the plant air at the pressure of 7 kg we are using. By this way, that emulsified whatever the oil, it will come into the surface of DAF tank, dissolved air flotation tank, where it is skimmed out off. Thus, emulsified oil will be removed from the as a free oil. That is a special technique. Here, actually, chemical treatment process thing finished. In DAF, how it functions, that one picture is here. I think two pictures is there, you can understand. Another picture is this. This kind of just oil is evolving, water and oil, thereby that emulsified oil will be separated out from the, it will come as a free oil, and it will be going down with sludge. So oil would be emulsified, also would be separated with the mainstream. Then coming to biological treatment, activated sludge process we have. That reduction of organics as BOD, biochemical oxygen demand, and COD, chemical oxygen demand, using bacteria, aerobic process it is. And sanitary water added to aeration tank, that actually helping to give the urea portion part. Actually, that bacteria food is urea, and sometimes DAP also may be required, but normally it is not required, diammonium phosphate. Aeration tank has the capacity of 20 hours residence times we have for that this bacterial growth. Or initially that bacteria has been generated by through cow dung. Cow dung has been put in this aeration tank. Thereby that bacteria initially started, and after breeding process, and we are giving the food as a urea, that bacteria consume this chemical part. Thereby BOD and COD has been reduced. And what quality we are achieving, that actually mixed liquor suspended solid, one testing we are doing, that if MLSS content is more than 2500 milligrams, 2450 milligrams per liter, then we can understand that it will work fine. Or as a food, as that molasses we are giving as a special food for the bacteria, so that they can breed more, actually breeding process. And if much less than 1000 milligrams per liter, then specially we need to add to that cow dung, again we need to add, but we need not to do that cow dung again. But only during commissioning phase we have added cow dung for this activated sludge process. Then dissolved oxygen of aeration tank outlet 2 milligrams per liter, thereby it is ensured. After that I have spoken already about the dissolved oxygen content minimum 4 milligrams per liter would be required for survival of the aquatic living organism, that is flora and fauna. So aeration tank also serving the purpose for maintaining this dissolved oxygen, DO. This is the picture of our aeration tank. Here if you see that aerators, surface aerators are moving, thereby it is giving the aerial oxygen, atmospheric oxygen to the bacteria, thereby bacteria can breed themselves and they can grow themselves, or they can consume, thereby they can consume the chemical part of the effluent water. This is the main process where actually chemical content has been reduced in the during treatment process. This is the major part of reduction of chemical quantity. Chemicals in the form of it may be oil also. Suppose if oil content more, we have another pond that we can store that, again we can treat here, but normally it is treated in this through this process, and thereby chemical content has been reduced and we can able to maintain the COD and BOD limit, thereby flora and fauna part also and statutory body limit also, norms also we can able to maintain. This is a surface aerator, thereby these fans are there, that is moving fans that is giving the oxygen to the water, thereby bacteria can get the oxygen there. It is the last part of the biological treatment, that is clarifier. That clarifier actually clarifies the water, clear effluent water in the upper portion, and bottom portion of the clarifier is again recycled to the aeration tank. Thereby that bottom portion going to aeration tank, thereby MLSS, mixed liquor suspended solid, maintained 3500 milligrams per liter. And one pump is in the bottom of the clarifier, that is biosludge pump, to maintain a circulation at 100 meter cube per hour continuously, so as to maintain this kind of water, this kind of quality. Suppose if bacteria content is very high, in that case bleeding operation, then also we need to remove some bacteria, that we have to separate out this bacteria. This is the clarifier. That clarifier top, from this top, this clarifier top water is going to the another pond named as guard pond. That guard pond ultimately mixes with the CTBT cooling tower blowdown and DM regeneration effluent water, then going to the river Hooghly finally. So after clarified water means it is treated effluent water. Actually here uh, what is our technology licensor? Initially Balkner Wabag technology, German technology. Recently it has been named as Vietec Wabag technology. They have initially given this technique for treatment, activated sludge process, aerobic bacterial treatment. This process helps for reduction of both COD and BOD, oil contaminated effluent. And whatever I have said, that urea being dosed for the survival, or want to mention our whole complex sanitary effluent being diverted to aeration tank, thereby bacteria get urea part as their survival food. Sometimes diammonium phosphate, DAP also dosing, and it has been used as nutrient for growing of bacteria. And then how plant has been commissioned and in for what way we have run, that initially cow dung has been used inside of aeration tank as trial and error basis to reduce the COD and BOD. Sometimes if influent what water we have received in our effluent plant, oil contamination remained on higher side, thereby breeding and growth of bacteria becomes easier. Urea addition may not be required also. Suppose sometimes oil content is more, and that they are getting the food, that oil from oil also, and that sanitary effluent that sometimes contain urea also, that food sufficient, then separately urea dosing may not be required. These above criteria basically depends upon through laboratory testing purpose, MLSS, MLVSS, and SVI, the sludge volume index. And MLSS is mixed liquor suspended solid, volatile suspended solid, and sludge volume index. And design value of MLSS is 3500 milligrams per liter. Normally, if it is in the range, then COD, BOD maintaining won't face any difficulty. So normal operation philosophy we have that MLS is found higher than 3500 milligrams, then we need to bleed out the extra suspended solid. Extra suspended solid through online bleeding mechanism through biosludge recycling stream. In reverse way, if MLS becomes lower than 100 milligrams per liter, then we may need to add molasses or cow dung to enhance the bacteria content, and MLS content automatically would be enhanced by, and consequently COD BOD reduction would take place to its desired value. The above concentration of microbial organism consumes the oil contaminated part and chemical part of the influent water stream, which resulted the enhancement of DO. DO means dissolved oxygen level, because oxygen consuming chemical are eaten up by the bacteria. This above dissolved oxygen level highly essential for survival of aquatic living organism. Minimum DO level supposed to be 4 milligrams per liter inside of water, thereby living organism can survive inside of water comfortably. Actually, main design philosophy, design basis, and biological treatment philosophy. Actually, four surface aerators are there. They are actually giving the oxygen to bacterial survival. These bacteria are actually reducing the BOD and COD level. And after that only it is going to clarification process in clarifier. Sorry. This clarifier bottom part again feeding to the aeration tank, and clarified top portion clear water being routed to guard pond as treated effluent through gravity drain philosophy, and 24 hours residence time being given to improve its DO. Further DO 4 milligrams per liter level is required. Here actually some statutory part. Statutory means governing body, and Central Pollution Control Board and State Pollution Control Board. Both are continuously monitoring what we are discharging. That through our internet system, that what quality and quantity we are discharging on minute wise or continuous basis, that continuous data is going to their server. This initially it was not there. Maybe it is implemented in 2010 or 11 or 12, sometimes like that. Since then it is continuing. That continuous data is going to CPCB and SPCB server. That what I'm mentioning, that sustainable development or protection of global environment. You know that water crisis is everywhere. Here we are getting the water in at 21 rupees per meter cube. Just a minute. Even in Western India also, that water cost is more, maybe 40 rupees per meter cube or 30 rupees per meter cube. But that's why they have already recycling of treated effluent started. But in our case, it is still statutory body has not dictated us that we need to recycle. But we are exploring in near future how this recycling of treated water can be done. Initially, maybe in our fire water network, or later on maybe in our cooling tower makeup. And next is COD load calculation basis. Actually, this is slightly design basis and theoretical part. Let's influent water COD is 200 milligram per liter or ppm. Influent water is 150 ton per hour or meter cube per hour, same thing if specific gravity equal to 1.0. Then therefore day wise water quantity would be 115 to 24, maybe 3600 ton per day. Then finally COD load may be calculated for designing for effluent treatment plant ETP. The 200 by, that is milligram per liter or ppm, that by 10 to the power 6 into 3600 into 1000 kg per day, that means 720 kg per day. Thereby we can understand what quality we are receiving, accordingly how much area or what type of effluent treatment plant we have to design. Then what is the volume, what is the kind of our treatment process supposed to be, that we can calculate here. And laboratory analysis also must be carried out so as to sustain its operation, that is MLSS, mixed liquor suspended solid, and VSS is volatile suspended solid, SVI sludge volume index. Thereby volume of actually 105 degree centigrade heating for 1 hour, and MLVS is 550 centigrade heating for 1 hour, and sludge volume index, volume of thickened sludge after half an hour. Actually, then next coming is treated effluent disposal. Clear process effluent stored in guard pond for 1 day. After overflowing of the guard pond, it is going to treated effluent sum. That treated effluent sum, sorry, it is mixed with CTBD and DM regeneration effluent, and polishing aerator is there. If suppose DO, dissolved oxygen level, is coming below 4 milligrams per liter, then we have to run it, further increasing this DO. Then finally this water pumped to Greenbelt Canal, and which is again mixed with our Hooghly River, then finally Bay of Bengal. And provision to recycle of off-spec treated effluent we have. That means if any case this treated water effluent quality is not achieved to or to satisfy our specific norms, then we can recycle that water. Again, we can reprocess the whole water. We have the provision like that. And during rainy season, that we have a separate unit, that surge pond. Their capacity is 16,000. Then if actually during heavy rainfall, that your it may not be required to treat, then simply we can discharge it to river Hooghly or satisfying our quality parameters. Then whatever the oil collected through skimmer or from bottom sludge, that we are also treating through centrifugation process. Bleeded sludge, biosludge from secondary calorifier, DAP tank drain, and screw and dewatery polytrade thickener. This is the another section of operation that we are calling as sludge handling system. And this is our actually flow diagram. That is wastewater treatment plant, how as a different unit, if you see NCU, LLDP, PP, associated unit, HDP, high density polyethylene unit, that effluent all received in TPI 1, then followed by equalization tank, then this OA it is going to DAP, then aeration tank. Here actually biological treatment taking place. Then clarifier, then guard pond, then treated sum, then disposal. And another red color pack is it is actually bottom part, that sludge portion. That chemical sludge actually, that water, then that sludge, that wet slop oil sum, then actually it is here centrifugation is there. After centrifuged solid material, again we are doing the incineration. Suppose if solid waste also by contamination is there and calorific value is there, then we cannot dispose that. We have the option, we can incinerate also. We have the incineration. Now question answer session. If anybody having any doubt, any question, or actually it's detailed design part, many things are there. Now if anybody having any question, you can ask me. Or
Thank you, sir, for sharing your knowledge. I hope our participant will be benefited a lot from this lecture. Sir, there are some questions from participants. I will read it for you.
okay, tell me.
First question, whether Cl2O3 and UV can be used for biological treatment of wastewater?
Please repeat once again.
Okay. Whether chlorine, ozone, and UV can be used for biological treatment of wastewater?
Actually, see, that can be used, but whenever that plant has been designed through some licensor, that licensor has thought that this kind of effluent and most economic way would be activated sludge process. That's why they have given this technology to us. Maybe what you are telling, that chlorine also that are also helping this kind of activity, but here actually technology licensor has given this process, and this process is serving the purpose satisfactorily, no issue.
Okay, sir.
That's why it is continued.
So their next question is, can artificial intelligence be integrated into biological wastewater treatment?
Actually, artificial intelligence, one session we have already in HPL, but till now, no such initiative or no such uh, much, we cannot proceed much on this issue. Already one session we have already.
Okay, sir.
And throughout the complex, wherever we can use this artificial intelligence, not only wastewater treatment, other plant also. But this is still it is very nascent phase, basic or initial phase. Maybe later on it would be.
Okay, sir. Next question. Please mention if any inorganic salts or ions are generated or released into wastewater.
Inorganic, actually, our main raw material is naphtha. Thereby, inorganic part or heavy metal part is very less actually. Actually, that is not at all coming in effluent with the effluent. Some inorganic part, catalyst part sometimes, but that is used as a solid and again recycling also. Sometimes if you see naphtha unit, nickel palladium catalyst, that, or molecular sheave in dryer use, those all are again recycled. Even where from that catalyst part you are purchasing, again they are reselling them at lower price. Thereby their noble metal they are extracting, again they are using. So that's why these parts are inorganic parts are not coming into the effluent treatment plant.
Okay, sir. Sir, there is another question. Can we go for electrocoagulation process?
Here actually coagulating chemical ferriculum we are giving. Ferriculum is giving
Yes,
for coagulation purpose only.
yes, yes.
Actually, depending upon the how much coagulation we require. Suppose quality, main thing is quality. If quality is maintaining that only suppose per day 20 kg coagulating chemical ferriculum we are reading using and thereby quality we are maintaining, TSS maintaining, everything is maintained, then we need not to use more. Even we can reduce also. That depends, all depends upon the effluent quality, what quality we are achieving or what quality we are getting, then that actually controlling the total chemical treatment process.
Yes. Sir, one more question. Does biological water treatment creates secondary pollutants in the form of bioactive compounds or enzymes?
Please repeat once again.
Yes, sir, I am repeating. Does biological water treatment creates secondary pollutants in the form of bioactive compounds or enzymes?
Actually this once we have attempted this actually during our treatment process huge oily sludge has been generated. That's why we have contacted with IIT Kharagpur. They have once tried to adopt that biological enzyme kind of thing so that they can it can be converted to biomass kind of thing, can be used as a fertilizer or something. That kind of approach once they have tried, but ultimately it has not succeeded or not or implemented or not, it has not fruitful actually. Actually, IIT Kharagpur once they have come our treatment process, and not only one of my friend IIT that biochemical engineering department HOD Ramkrishna Sen is there.
Okay, sir.
Dr. Taposh Manna might be knowing.
Mhm. Yes.
Taposh Manna very close to me. He was my actually BTech roommate. You might be
Yes,
knowing
sir.
Dr. Taposh Manna.
Yes, sir. Yes. Okay, thank you so much. Thank you very much, sir. And thank you once again.
Thank you for listening me. Thank you giving me opportunity to tell something about our Haldia petrochemicals, how we are treating. And any kind of you need or any assistance in near future also you can contact with me. That contact all details with we have with our Sunil Kuila. You can tell
Yes.
him.
Okay, sir.
He has all the contacts with me. Okay.
Thank you, sir.
Okay. Thank you.
With this, we are ending today's session here. Tomorrow, we have our third day of FDP, and the speaker is Mr. Pranab Sinha Mahapatro, Senior Manager at MCPI Private Limited. He will be giving his lecture on industrial wastewater treatment, a sustainable approach towards cleaner environment. Now, dear participants, attendance link is live. It will be active for half an hour only. So please mark your attendance within half an hour. Thank you, everyone. Have a nice day.
Thank you, Asida,
Thank you. Thank
for
you.
your cooperation and giving us your valuable time. I hope your operating ideas and what you are actually following at your end that will help us.
Thank you,
Okay.
Sunil. Thank you once again. Thank you.